Welcome back, guys. In this video, I'm going to solve question 6 on grade 12 functions. This question is from paper 1 from DBE from May-June 2022 past exam. In order to solve this question, you need the knowledge on parabola. So this is the question 6. So in this video, we are going to learn how to calculate the coordinate of the turning point of a parabola. You are going to learn how to determine the equation of a straight line passing through 2 points. You are also going to learn how to determine the coordinate of the point of contact between a tangent and a parabola. And lastly, you are going to learn how to solve quadratic inequalities. Okay, so let's get started. Okay, question 6.1. Calculate the coordinate of E, the turning point of F. And this question is 3 marks. Okay, so let me get the graph. It's question 6. There's question 6. This is the graph. You are given the graph of f of x. You can see the sketch below shows the graph of f of x is equal to negative x squared minus 6x plus 7. C is the y-intercept of f. There is C, the y-intercept of f. A and B are the x-intercept of f. A and B are the x-intercept of f. D is a point on f. There is D, a point on f. And you also have E, which is the turning point of f. You are told that you can see calculate the coordinate of E, the turning point of f. This is the turning point of f, which is E. You need to calculate the coordinate of this point, which is the turning point of f. Okay, so this is the equation of f. F of x is equal to negative x squared minus 6x plus 7. You are given it, you can see. Okay, now to get the coordinate of the turning point, you can use this formula. So you can use the first derivative to find the x coordinate. When you find the x coordinate, you plug the x coordinate inside f of x, and then you are going to find the y coordinate. Okay, you can also use this formula. X is equal to negative b over 2a, right? So you can see this is your a, which is negative 1, and your b is negative 6, your c is 7. So you have a, b, c. A is equal to negative 1, b is equal to negative 6, and c is equal to 7. You can use this formula, right, to get the x coordinate of the turning point. When you get the value of the x coordinate, you plug inside this, and then you are going to get the y coordinate. Okay, so you can use this formula or this formula, and this formula is obtained from the quadratic formula. This is the quadratic formula. You can see you have x is equal to negative b over 2a. Can you see the part in green? So you pull out this part, and then you have this formula. So to get the x coordinate of the turning point, I'm going to use this formula. X is equal to negative b over 2a. This formula, right? And this is equal to, you have negative, what is your b? Your b is negative 6. So in alphabetical order, you have a, b, c. Your b is negative 6, right? So you have negative b. Your b is negative 6 over 2a. Your a is negative 1. So it's a, b, and c, right? Your a is negative 1. There is an invisible 1 there, right? Negative 1. Okay. And this is equal to, you have 6 there over negative 2. You can see that this is positive. So 6 over negative 2. This will be negative 3, right? And so you have the x coordinate of the turning point. Now to get the y coordinate of the turning point, you are going to take this value and you plug it inside f of x there. So you are going to take f of negative 3. Okay, so f of negative 3 is equal to, you plug negative 3 wherever you have x. So you have x there and x there. So it's negative x squared. Your x is negative 3, right? Square minus 6x. So you have minus 6 times x, which is negative 3, right? Okay, plus 7, right? And so f of negative 3 is equal to, this is a 9, so you have negative 9 there, can you see? And this is 18, negative times negative, 6 times 3, 18. So you have 18 minus 9, which is 9, and 9 plus 7 is 16, okay? Right? And so the coordinate of the turning point E are negative 3 and 16, okay? So this is the y coordinate and this is the x coordinate, negative 3 and 16, you can see, okay? So this is how you calculate the coordinate of the turning point on a parabola. Okay, now let's move on to the next question, which is 6.2. Okay, let me make a line here. Okay, and let me do this. Okay, now 6.2, write down the value of k. This question is 1 mark. Okay, you need to write down the value of k. You can see k is the y coordinate of the point D, and you can see the point D is on the graph of f. You can see this is the graph of f, right? And you have the point D on the graph of f. Okay, so k is the y coordinate of the point D. To get the y coordinate, you are going to plug the x coordinate. The x coordinate is negative 5, you can see. So when you plug negative 5 inside f, you are going to get the y coordinate, which is k. Okay, so you have the point D, which is a point on f, right? It is on the graph of f. You can see this is the graph of f. The point D is on the graph of f. This is why I can say D is a point on f. Okay, so to get k, you are going to take f of negative 5. Okay, so you have f of negative 5, and then you plug negative 5 wherever you have x. So you have x there, you have x there. You are going to plug negative 5 inside there to get the value of k, because k is your y coordinate. Okay, your x coordinate is negative 5. So f of negative 5 is equal to, you have negative x squared, so it's negative, your x is negative 5 square, right? You have negative x, this is your x squared, right? And then you have negative 6x, so it's negative 6x, your x is negative 5, right? And then you have plus 7, okay? And then f of negative 5 is equal to, this is negative, and this is 25. Can you see negative 5 to the power of 2? You raise everything there to the power of 2. It's going to give you 25. And then you have negative times negative, which is positive. You have 6 times 5, which is 30, right? And then plus 7. Okay. And so f of negative 5 is k, right? This is the same as k. This is your y coordinate. So I can say k is equal to, you have 30 minus 25, which is 5, and then 5 plus 7, which is 12. Okay, so the value of k is equal to 12. Okay, I hope it's clear. Now let's move on to the next question. Now question 6.3. Okay, let me get the question again. Question 6. Okay, so question 6, the sketch below shows the graph of f of x is equal to negative x squared minus 6x plus 7. C is the y-intercept of f. A and B are the x-intercept of f. D is a point on f. So you have C, which is the y-intercept of f, and you have A and B, which are the x-intercept of f. You have D, which is a point on f. There's D, okay? And so the question says, question 6.3, determine the equation of the straight line passing through C and D. This question is 4 marks, okay? Let me get the sketch on the slide. This is the sketch that you are given, okay? This sketch, you have it there, okay? I can close this. So you have point D, there's point D, with coordinate negative 5 and 12. Remember from the previous question 6.2, k is equal to 12. You calculated for k. and it was equal to 12. So the coordinate for point D are -5 and 12. And you also have point C. Okay, what are the coordinates of point C? You can see from the equation. Let's see from the equation. You can see from the equation of f, you have -x squared, -6x plus 7. So your constant is 7. This constant tells you what the y-intercept is. So f is cutting the y-axis at 7. You can see the constant tells you that f is cutting the y-axis at 7. This is what the constant is telling you. So when the equation of a parabola is given in this form, you can see that the constant is your y-intercept. So this is the form ax squared plus bx plus c. Remember that form of a parabola, ax squared plus bx plus c. So this is your c, and this constant is your y-intercept. So you know the coordinate of this point will be 0 and 7, right? This is your x and this is your y. Remember the second coordinate is your y, and your y is 7. Okay, you can see that. And so you have this straight line, right, from C to D. Now the question is to calculate the equation of this straight line passing through C and D. Okay, so you have the point C. There's the point C with coordinates 0 and 7. You can see. And you also have the point D with coordinate -5 and 12. So this is your K. You replace it with 12. Okay, your K is equal to 12. You calculated K in the previous question 6.2. To get the equation of the straight line, you can use this formula, which is known as the point slope form, or you can use this formula, which is known as the slope intercept form. So you have the point slope form and the slope intercept form. You can use either of the formula, this one or this one. Any will give you the correct answer. So in this video, I'm going to use this formula. Okay. So now what I want to do, or what you want to do, is to get the gradient. The gradient is m. So the gradient m is equal to, you have this part, you divide it by this part. Okay, so this divided by x minus x1, you can see, and this is equal to m. And now the gradient m is equal to, I need to use 2 points which are on the line. Okay, the 2 points are C and D. So when taking the gradient, you must use any 2 points which are on the line. So I only have C and D. I'm going to use them because they are on the line. You can use any 2 points which are on the line to get the gradient. Okay, and I'm going to start from C to D, or you can start from D to C when taking the gradient, but I'm going to start from C to D. Okay, my y will be 7 and my y1 will be 12. You can see the second coordinate is your y. So this is my y and this is my y1. Okay, so I have 7 there for y minus y1, which is 12. Okay, over, now I have x minus x1. So I'm starting from C to D. You should keep that order. If you are starting from C to D, you do the same even in the denominator. Don't swap around. And then now you start from D to C. You are going to get a wrong answer. If you were starting from C to D in the numerator, you should do the same from C to D in the denominator. Okay, so now my x from C is 0 minus, now my x1 from D is -5. You can see, so I have -5 there. Okay, and so this is equal to, I have 7 minus 12, which is equal to -5, and I have minus there and -5, which is equal to a +5. So I have -5 over 5, and this is equal to -1. So the gradient of the line is equal to -1. You can see this is a negative value, and it tells you that the line is falling. You can see it falling, or it's decreasing, because the gradient is a negative value. Okay, you can see that. Now to get the equation of the straight line, I said you can use this formula or this formula. You're still gonna find the same answer. Okay. In this video, I'm going to use this formula. Okay. So I'm using this formula. Now I have y minus y1, right? So y minus y1. Okay, I'm going to replace only y1 and x1 when I'm trying to determine the equation of the straight line. So you have to replace only y1 and x1. Okay, and you can use any point to replace your y1 and x1. Any point will work. In this video, I'm going to use C. You can also use D. Okay, you'll still find the same equation. So y1 from C, this is y, right? So it's 7 is equal to, what is the gradient? The gradient is equal to -1, right? You open your bracket, and x, remember you are only replacing y1 and x1. Okay, so minus x1, I'm using the point C, right? So my x is 0, you can see, and then I close the bracket. Okay, you can pause the video and try to use the point D. You are going to see that you are going to find the same equation in the end. Okay, and now I carry on. Now this is y is equal to, you have -1 times x, which is -x, and you have -1 times -0, right? This is 0. Okay, and then it's plus 0, right? So you have -7 there. You bring it to the other side, it's plus 7. Okay, and so this is the equation of the straight line passing through C and D. The equation is y is equal to -x plus 7. Okay. 6.4. Let me get the question again. Question 6. Okay. So what is the question saying? A tangent parallel to CD touches F at P. Determine the coordinate of P. Okay, this question is 4 marks. Okay, so let me get the sketch on the slide. This is the sketch so that you can understand the question. Okay, so this is the sketch that you are given. You can see you have point C and point D. Okay, you know the coordinate of point C from the previous question. Okay, this is the line CD, right? You can see. Okay, so let me close this. We don't need it for now. Okay, this is the line CD. We are told that there is a tangent which is parallel to CD. So this is CD and the tangent is parallel to the line CD. Okay, and the tangent touches F at P. So this is the graph of F. The tangent is touching the graph of F at P. Now the question is to determine the coordinate of P. P is the point of contact between the tangent and the parabola, or between the tangent and the graph of F. The graph of F is a parabola. Okay, so you can see if you were to draw a line parallel to CD below this line like this, you can see this is not a tangent because it's cutting or it's touching the graph of F twice. You can see it's touching there or cutting there, 1 and there 2, so twice. And you can see that this line cannot be a tangent. For a line to be considered a tangent, that line must touch the curve or the parabola only at one point. Okay, so any line that you can draw below the line CD, let's say this line, is not going to be a tangent, because any line that you can draw below the line CD will always cut the graph of F or cut the parabola twice. You can see this line is cutting the graph of F twice, there and there, so twice. And again, this line cannot be considered a tangent. Okay, so you can't get a tangent below this line because you can see this parabola still continue. You can see it still continue. Okay, so the tangent cannot be obtained below the line CD because any line that you can draw below the line CD will always cut the graph of F twice. Okay, so for a line to be considered a tangent to a curve, that line must touch the curve only at one point. So you can see the tangent can only be obtained above this line CD. So it can be somewhere, can you see there? Okay, right? You can see. So it's touching the curve or the parabola at that point. Can you see that point? And this point is known as P. Okay, let's call it P. Okay, so this line and this line, let's get rid of them. They are not tangent, okay, because they are cutting or they are touching the parabola twice. Okay, a tangent must touch the curve only at one point. Okay, and so this is the line which is considered a tangent to the graph of f, because it's touching the graph of f only at one point. The point is P. Okay, let's call it T. Okay, T for tangent. So this is the tangent. Okay, it's touching the graph of f at one point, and the point is known as P. Okay, now the question is to find or to determine the coordinate of the point of contact, which is P. Okay, we need to determine the coordinate of that point. Now this is the formula to remember if you wanna determine the coordinate of the point of contact. You have mt is equal to the first derivative, okay, m for the gradient and t for tangent, okay, t for tangent. So you take the gradient of the tangent is equal to the first derivative. You take the first derivative of the equation of the graph of f. So you have the graph of f, you take the first derivative of the equation of f, and then you make it equal to the gradient of the tangent. So you have m subscript t is equal to the first derivative. Okay, now what is the gradient of the tangent? You can see the two lines. You are told that the two lines are parallel to each other. And when two lines are parallel to each other, they also have the same gradient. Okay, so since this line, the line CD, is parallel to the tangent, they have the same gradient. Okay, and remember in the previous question, question 6.3, you calculated the gradient of the line CD, it was equal to -1. And since the gradient of this line CD is equal to -1, the gradient of the tangent will also be equal to -1. So m subscript t is equal to -1 because the tangent is parallel to the line CD. When two lines are parallel to each other, they have the same gradient. Okay, the gradient of the line CD is equal to -1, and so the gradient of the tangent will also be equal to -1. Now you have the gradient of the tangent, which is equal to -1. Now you need to take the first derivative. You are going to take the first derivative of the equation of the graph. Okay, what is the equation of the graph? F of x is equal to, you can see from the question, you are given it. Can you see question 6? That is -x squared minus 6x plus 7. Okay, -x squared minus 6x plus 7. Okay, so you are going to take the first derivative of the equation of f of x, which is f prime x, like this. Okay, so you need to know your calculus. Please check the videos I'm going to post on calculus if you are still struggling on taking the first derivative. Okay, so f prime of x is equal to, you have -2x, right? You take that 2 times the -1, you have -2, x to the power of 2 minus 1, which is x. Okay, and then you have -6. Okay, and this gives you 0. So the first derivative is equal to -2x minus 6. So now you have the gradient of the tangent and you also have the first derivative. Okay, let's use this formula. This is the formula that you have to remember if you want to calculate the point of contact between a tangent and a curve. Okay, so what is the gradient of the tangent is equal to -1. Okay, you have -1 is equal to the first derivative, you have it there, -2x minus 6. Okay, and so you take this -6 to the other side, you have 6 minus 1. You can see that -6 to the other side, it becomes a +6. So you have 6 minus 1, which is equal to 5. Okay, and this is equal to, you only remain with -2x on the other side. Okay, and so to solve for x, you need to divide by -2 on both sides. You can see that you divide this by -2, you only have x. Okay, when you divide by -2, which is equal to, you also divide by -2 this side, you have -5/2. Okay, so you divide by -2 on both sides. Okay, now you have the x coordinate of the point of contact. which is the x coordinate of the point P. Now you need the y coordinate of the point P. What are you going to do? You are going to take this value, you plug it inside f of x to get the y coordinate. Okay, so you are going to take f of negative 5 over 2, right? F of negative 5 over 2. So you are going to plug negative 5 over 2 wherever you have x. So you have x there and you have x there. You are going to plug negative 5 over 2 wherever you have x. Okay, so this is equal to, you have negative x square. Your x is negative 5 over 2 square, right? Minus 6x, right? You have minus 6x. Your x is negative 5 over 2, right? So you are plugging negative 5 over 2 wherever you have x. Okay, and then plus 7. Okay, f of negative 5 over 2 is equal to, use your calculator. Okay, so you have negative, in bracket you have negative 5 over 2. I hope you can follow. Square minus 6 times, in bracket you have negative 5 over 2. You close your bracket and then plus 7, and this is equal to, you have 63 over 4. Okay, so f of negative 5 over 2 is equal to 63 over 4. Okay, so this is the y coordinate of the point of contact, the point P. Okay, and so the coordinate of the point of contact, the point P, are negative 5 over 2 and 63 over 4. Okay, so this is how you determine the coordinate of the point of contact. Okay, so let's move on to the next question, which is 6.5. Okay, now question 6.5. Okay, let me get the question again. This is the question 6 from May-June 2022. Okay, so what is the question? 6.5. For which values of x will f of x minus 12 be greater than 0? Okay, you need to find the values of x for which f of x minus 12 is going to be greater than 0. And this question is 2 marks. Okay, now you are given f of x. There is f of x. Okay, so you have f of x minus 12 greater than 0. Okay, let's get f of x down. This is f of x. You have it there. You can see negative x squared minus 6x plus 7. You can see. And so you have negative 12 there. So you have negative 12 greater than 0. Okay, you can see that. Let me close this. So this is an inequality. You need to solve this inequality so that you can find the values of x for which f of x minus 12 is going to be greater than 0. Okay, so you have negative x squared and then negative 6x, and then you have 7 minus 12, which is negative 5, right? And greater than 0. Okay, and now you can see the coefficient of x squared is negative 1. Okay, let's change this to a positive 1. So what we are going to do is to multiply by negative 1 throughout. Okay, so when you multiply this by negative 1 throughout, this is going to be x squared. You multiply this by negative 1, this is going to be plus 6x. You multiply this by negative 1, this is going to be plus 5. Okay, and you multiply by negative 1, this is going to change to less than. Okay, from greater than to less than, because you are multiplying by negative 1 throughout. Okay, and you have 0 there. Okay, 0 times negative 1 is 0. Okay, okay, now what you want to do is to factorize this. Okay, so you are going to have 2 brackets. Okay, like this, and you have x squared there, so you are going to have x and x there. Okay, because x times x is x squared. And now you have 5 there. You know that 5 is equal to 1 times 5. 1 times 5 is equal to 5. And from 1 and 5, you can get the middle term, which is 6, because you know that 1 plus 5 is 6. Okay, so I can have 1 there and 5 there. you can see that 1 times 5 is 5, 1 plus 5 is 6. Okay, so you can get the middle term. And since you have plus there, you are going to have the same signs inside the bracket, and those signs are going to be plus and plus. Okay, and so less than 0. Okay, and now from here, this is what we have to do when solving a quadratic inequality. A quadratic inequality is an inequality which is of the second degree. Okay, you can see the highest degree is 2, right? And this is a quadratic inequality. So when solving a quadratic inequality, this is what we have to do. You have to get first your key numbers. Okay, the key numbers of this inequality are, when you solve this part, you make it equal to 0, x is equal to -1. You do the same here, you make it equal to 0, you solve for x, x is equal to -5. So the key numbers for this inequality are x is equal to -1 and x is equal to -5. You can see that when you solve this part, you get x is equal to -1. You solve this part, you get x is equal to -5. Okay, so the key numbers for this inequality are x is equal to -1 and x is equal to -5. Okay, now from here, you have to get the key numbers on the number line. Okay, this is the number line, and you have -1 there, and you also have -5 there. I hope you understand that, because if you can go to that side, you have -6, -7, -8, -9, -10, and all the way to -infinity. Or you can go this side, after -1, you have 0, 1, 2, 3, 4, 5, all the way to positive infinity. Okay, so you know that -5 is before -1. Okay, on the number line. I hope you understand that. So now you can see the key numbers are dividing the number line into 3 intervals. You can see you have this interval and this interval and this interval. So you have 3 intervals. Okay, you have the interval before -5, and you also have another interval between -5 and -1, and you also have another interval after -1, this one. Okay, and now since there is no equal sign there, it means that -1 and -5 are not part of the inequality. Okay, because there is no equal sign there, -1 and -5 are not part of the inequality. You have to show that on the number line. You are going to show that with an open circle, like that. Okay, so when you have an open circle, it means that -5 and -1 are not included. Okay, when talking about closed circle and open circle, I want you to understand this. This is an open circle, right? And this is a closed circle. Okay, so when a number is not included on the number line, you are going to use an open circle. If a number is included, you are going to use a closed circle. Okay, so this is when a number is not included, and this is when a number is included. You can see -1 and -5 are not included on the number line. This is why I have an open circle. You can see you have no equal sign there. So -5 and -1 are not included. Okay, now from here, what you want to do is to test your intervals. Okay, remember you have 3 intervals. Okay, you have the interval before -5, this interval. So before -5, you have -6, -7, -8, -9, all the way to -infinity. So you can use any number before -5 to test this interval and see if your answer is going to be a positive or a negative answer. Let's see that. Okay, I'm going to use a calculator to do this quickly, but you can do this mentally. Okay, let me use a calculator. You can do it mentally. Okay, so before -5, I can use -6, -7, -8, or -9, or -10. Okay, let me use -9. Okay, so I'm going to plug -9 there and -9 there and see if the answer is going to be a positive or a negative answer. Okay, so let me plug -9. So I have my bracket, and in the place of x, I put -9 and then +1. You close your bracket, you open another one, you have x there. In the place of x, you put -9 and then +5. You close your bracket. This is equal to 32. Okay, you can see 32 is a positive answer. Okay, So if you use any number before -5, you are going to have a positive answer. Okay, any number that you can use before -5 will give you a positive answer. Okay, you can see I have 32, which is a positive answer. So before -5, I have positive. Let me clean this. Now you are going to use any number between -5 and -1. Okay, so between -5 and -1, there is -2, there is -3, -4, right? All those numbers, you can use them to test this interval. Okay, let me use -3. You can see -3 is between -5 and -1. Let's plug -3 in there where there is x. Okay, so I open my bracket. You have x there. You put -3 and then +1. You close your bracket. You open another one. You have x there. You put -3 +5. You close your bracket, and this is equal to -4. Okay, you can see is a negative answer. Okay, so in this interval, if you use any number in this interval, the answer is going to be a negative value. Okay, so let's have negative there. Okay, now let's test this interval, the interval after -1. Okay, after -1, you have 0, 1, 2, 3, 4, 5, all the way to infinity, or all the way to positive infinity. Okay, let's clean this. Let's use any number after -1. So you can use 0, 1, 2, 3, 4, 5, 6, 7. Okay, let me use 7. Okay, because you can see 7 is after -1. Okay, I'm going to plug 7 in there. So this is my bracket. You have 7 there, +1. You can see, you close your bracket, you open another one. You have x there, you put 7 +5. Okay, and the answer is 96. Okay, so if you use any number after -1, you are going to have a positive answer. Okay, so you have positive there, right? Okay, let me close this calculator now. Now you can see when using the numbers in the intervals, these are the signs that you are going to get. Okay, now when you look at this, what does this tell you? Less than 0, it means negative. So only this interval is going to satisfy, because you have less than 0, which is negative, and you have negative only in this interval. And the answer to this will be between -5 and -1. Okay, so you can write this down as x greater than -5. Okay, and x less than -1. You can see less than -1, you go there, greater than -5, you go there. So you are in this interval, in the interval between -5 and -1. Okay, this is how you solve this inequality. So for which values of x will f of x minus 12 be greater than 0? For the values between -5 and -1. You can test this using your calculator. When you take all the values between -5 and -1, you are going to see that the answer will always be greater than 0. Okay, you can do that with your calculator. I hope it's clear. So this is how you solve a quadratic inequality. Okay, we are done for today with question 6 from May-June 2022. If you find value in the videos, please show that with your likes and put your comment in the comment section. I'll be glad to reply to your comment. As for now, we are done. See you next time and take care.